In this video, we're going to look at how we differentiate implicit functions. Now, an implicit function, we have three examples of implicit functions. Here we have xy plus y squared equals 2, 2xy plus 3y squared minus y is equal to 0, and 3x squared minus 4x y squared plus y cubed equals x cubed. Now, these are implicit functions as there's a mixture of x and y terms, and you're not just given y as a function of x. So this, for example, would be an explicit function, so where you can see your y is given as a function of x, and that doesn't happen in an implicit function. So it's a wee bit different, a wee bit more tricky to differentiate an implicit function, as we will see. So it says, note some implicit functions could be rearranged and differentiated as normal. So for example, this one here, we have x squared plus y squared equals 9. You could write this as x squared, I'll just write it again, x squared plus y squared equals 9. You could rearrange, make y squared the subject, 9 minus x squared, and then you could say then your y is equal to 9 minus x squared, the square root of all that. Instead of writing the square root, I'm going to write to the power of a half. You then could go on and say your dy by dx, this is now a function of a function, so differentiate with respect to the bracket, you'll have a half upon the bracket, 9 minus x squared, and the bracket is now reduced its power by 1, so now minus a half, and differentiate inside the bracket will be minus 2x. So multiply the half by the minus 2x and you'll get minus x upon 9 minus x squared to the power of minus a half. Okay, so that's how you could do that one. But there's many cases where it's not just going to be just so easy. So we're going to have to look at how we go about doing this. Okay, as I said, it's often not easy to rearrange and make y the subject. So we're going to use the chain rule an awful lot in this to explain how we do this. So remember what your chain rule is. Dy by dx is equal to dy by du times du by dx. So for example, if you're differentiating y with respect to x, that just means differentiate y with respect to x. It's just dy by dx. Via the chain rule then, if we're differentiating y squared, that really means you differentiate your y squared with respect to y, and then you multiply by dy by dx. Multiply by dy by dx. So let's have a look at the y that is. If you look at, you can differentiate y squared with respect to y, and if you do this, it's just like cancelling down when you multiply that dy and that dy cancels, and that is going to give you the derivative of y squared with respect to x. So if you have a look at what that is, so what do you get if you actually differentiate y squared with respect to y? You get 2y dy by dx. Okay, so in general, folks, if you're differentiating a function completely in terms of y, just differentiate with respect to y, and then fire a dy by dx on the end. So if for example, if I was doing, no idea, right, if I was differentiating 7y cubed with respect to x, 7y cubed with respect to x, I would just say differentiate the 7y cubed with respect to y will give me 21y squared, and then I'd fire, this thing is playing up, apologies, I would fire a dy by dx on the end, and that would be it. Okay, we're just going to look at properly at this now and give it in our notes. So in general, here we have the in general thing here. In general, if you differentiate y to the power of n with respect to x, you're going to get n y to the power of n minus 1. So that's just you've differentiated your y term with respect to y, and then you fire a dy by dx on the end. Okay, we're going to go on and look at a couple of examples on this, and this one in particular is a wee bit different. Okay, I'm going to show all the steps for the first one here. We are differentiating your y to the power of 6 with respect to x, which means we really have to differentiate y to the power of 6 with respect to y, and then multiply by dy by dx. Okay, if you do that, if you differentiate y to the power of 6 with respect to y, you'll have 6y to the power of 5 and times dy by dx. if I was doing this myself properly, I would not put this line in. I would just skip to this. Remember, this is just differentiate the y term with respect to y, and then fire dy by dx on the end. Okay, part 2 is a wee bit trickier. Part 2, what we have here is a product. So we've got a function, and then we've got a function here. So there are two functions multiplying together. So we want to actually differentiate this, and if it's a product, we're going to use the product rule. Now go back and watch the video on the product rule, and the key point I want you to watch in it is how I explain how we do this. So the way I said to do this was write down the first, and then differentiate the second, then write down the second, and differentiate the first. And when I say differentiate, I mean it's differentiate with respect to x. So I'm going to look at this as two separate bits. I've got the 3x, and I've got the y to the power of 4. So there's the two bits that I'm talking about. So the first thing I said was write down the first, which is just 3x, and differentiate the second. So I'm just going to put that in a bracket. So if we differentiate y to the power 4, you're going to get 4y cubed, if I left myself enough room, times dy by dx. Okay, plus, then we said write down the second, so that's y to the power 4, then differentiate the first. I'll just put it in a bracket. 3x differentiated with respect to x is just 3. Okay, that's a bit of a mess. We'll just tidy it up. So we have 3x times 4y cubed, which is going to be 12xy cubed, times dy by dx, plus then 3y to the power of 4, and that's it. Okay, so just to run through that again, so very quickly what I've done is I've write down the first, differentiate the second, and both of these are being differentiated with respect to y, with respect to x, apologies. So I was write down the first, differentiate the second, and write down the second, differentiate the first. So it's handy enough actually to do what I've done here is just to underline the bit so you can see this is my first bit, this is my second bit. Okay, it says find dy by dx in terms of x and y if 3y squared plus 2y plus xy is equal to x cubed. Okay, I'm just going to write this down again. So what do I have? 3y squared plus 2y plus xy is equal to x cubed. And I'm just going to say at the side here, differentiate with respect to x. So I haven't said dy by dx equals, and we'll see why in a wee minute. So I'm going to say this bit differentiates to give me. So this is a nice one. This is just all completely in terms of y. So just differentiate with respect to y to give you 6y, and then slap a dy by dx on the end. This one again is nice and easy. It's just all in terms of y. So differentiate with respect to y, you get 2. Then dy by dx. Then this one is a product. So a product one, I'm going to put it in brackets. Hopefully I've left enough space. Write down the first, differentiate the second. So there's my first bit, and there's my second bit. So my first was x. Y differentiated with respect to x is dy by dx, remember? Then what we have to do is just write down the second, which was y, and differentiate the first. So if you differentiate the first, that means differentiate 1 in this case, or differentiate x in this case, which is just 1. Okay, and then we've got to do the other side of the equals. So you've got to differentiate both sides of the equation and differentiate x cubed with respect to x. You're going to get 3x squared. Okay, bit of a mess, so let's just tidy up. What we have here is 6y dy by dx plus 2 dy by dx plus x dy by dx plus y is equal to 3x squared. Okay, we're going to go up here to finish this off. What we want to do long term here is to make dy by dx a subject. So I'm going to group all the dy by dx's on one side. Everything that has not got a dy is not a dy by dx term is going to get fired over to the right hand side. So I've got 3x squared already on the right hand side. I'm going to bring that y across so it becomes minus y. Now on my left hand side, as I said, I'm going to group all my dy by dx terms, and I'm going to group them all together. So I'm going to factorize dy by dx out. So I'll have 6y plus 2 plus x upon my dy by dx. So the question said find dy by dx in terms of x and y. So your dy by dx is equal to, nice horizontal line here, 3x squared on the top line, 3x squared minus y, sorry, on the top line, and bottom line is going to be 6y plus 2 plus x. So the strange thing about this question is you've got your dy by dx, here it is, but it's in terms of x and y. So what we are used to with explicit functions, and where y is written explicitly in terms of x, your dy by dx is completely in an x expression. It's completely in terms of x. For implicit in functions, not always, but more often than not, your dy by dx is in terms of both x and y. So you need the x value and the y value of a coordinate to be able to find the gradient. Okay, this next example says find the value of dy by dx and dy by dx squared at the point 1, 0 if 4x squared plus y squared minus 4y equals 0. Okay, I'm just going to write this down again. 4x squared plus y squared minus 4y equals 0. And all we're going to do here is we're going to say differentiate. Again, differentiate with respect to x. So I'm going to differentiate the 4x squared term. If you differentiate the 4x squared term, what you're going to get is going to be 8x. Differentiate the y squared term. So differentiate with respect to y, you get 2y, and then slide the x. So this is playing up again. And then we want to differentiate your 4y. So that's just going to be minus 4 dy by dx. Minus 4 dy by dx, and on the right hand side that's equal to 0. So here we want to just isolate all the dy by dx terms. So you're going to have 2y minus 4 upon dy by dx is equal to minus 8x. So you can say your dy by dx is equal to, dy by dx is equal to then minus 8x over 2y minus 4. 2y minus 4. Now we could write that a wee bit nicer. If you multiply through the top line by minus 1 and also the bottom line by minus 1, you will get 8x over 4 minus 2y. Okay, so you've got that, and again, another thing we could do is just divide through by 2 again and make it a wee bit easier to give you 4x over 2 minus y. Okay, it's said for us to then first of all find the value of dy by dx. So just say at 1, 0, your dy by dx is going to be equal to, so it's going to be just 4 on the top line over 2, which is just going to be equal to 2. Okay, next thing we want to do is find our d2y by dx squared. So I'm just going to write my dy by dx down again. dy by dx was equal to 4x over 2 minus y. And I've just written it down again because I'm going to have to do the quotient rule to find my d2y by dx squared. So I'm going to say my u is equal to 4x, my v is equal to 2 minus y, and then I'm going to have to differentiate both of these things with respect to x to be able to do my quotient rule. So du by dx is going to be equal to 4, and dv by dx is going to be equal to minus of dy by, it is going to be equal to minus 1 dy by dx. Okay, we're just going to go ahead with that and then say our d2y by dx squared then is equal to, and I think it's useful in this case to write down the formula, v du by dx minus u dv by dx all over v squared. And then we'll just continue this on up here, up at the top, just to figure out what that is. So this is just continuing on. d2y by dx squared then is equal to, so the v was 2 minus y. The v was 2 minus y. My du by dx was 4. Then minus my u, which was 4x, times my dv by dx, which was minus 1 times dy by dx, so minus dy by dx. Okay, apologies with this. So why this is doing it is going to be my v squared. So 2 minus y all squared. So we're now going to say at 1, 0. So at 1, 0. So a reason I've set it out this way, this is not the this is the general equation for d2y by dx squared, but we haven't put in my dy by dx in terms of this. Now the reason you would have to do that if we didn't have a point and you just looking for the general equation of d2y by dx squared, but we want a specific point here. So we already know at 1, 0, we know the value of dy by dx. Okay, so we can use this already. So we'll just tidy this up one wee bit we'll just fire these things in and we'll see how we get on here. So we'll just say our d2y by dx squared then is going to be equal to, so we had 2 minus y, so our y value was 0, so it's just going to be 2, then times 4, then minus 4 times the x, so the x value was 1, so that's just going to be 4, and my dy by dx was at 1, 0 was 2, so that's going to be minus dy by dx, so minus 2, all divided by, and the bottom line is going to be 2 minus 0, so that's just going to be 2, and then squared. Okay, that's an absolute mess, so let's tidy it up. Top line is going to be 8 plus 8, and then divided by 2 squared, which is going to be 4. 8 plus 8 is 16, divided by 4 gives you 4. So there we have it. That is, we have found, let's just check our question, we have found the value of dy by dx. It was somewhere, it was equal to 2, and you've also found your d2y by dx squared is equal to 4, and I was at both of the points at 1, 0. Okay, last example. I've given up trying to use this pen, so I'll just talk through this when I've written out the solution. We'll just talk through it. It says in this example, find the equation of the normal to the curve 3x squared minus xy minus 2y squared plus 12 equals 0 at the point 2, 3. Now, I've write out the question again, and the equation I should say, and then differentiate with respect to x. So the only thing we'll add in here, a couple of wee lines, to get from my 3x squared differentiates to give you the 6x. So that's all I've done here. Now this is me differentiating my xy. So xy is a product. So write down the first, that's your x. Differentiate the second, that's your dy by dx. Write down the second, that's your y. Differentiate the first, that's the x, which gives you 1. And differentiate the minus 2y squared. So that's going to be minus 4y times dy by dx. 12 differentiates with respect to x to give you 0, and 0 differentiates with respect to x to give you 0 as well. All I've done now is isolated my dy by dx's. So I've got minus x dy by dx, and I've got minus 4y dy by dx. So that's brackets minus x minus 4y upon dy by dx. Then fire your minus 6x across, it becomes minus 6x, and just be careful that's minus y going across, so it becomes plus y. So you have dy by dx equals minus 6x plus y all over minus x minus 4y. So there's more things negative than positive here, so multiply the top and the bottom by minus 1 to give you 6x minus y upon x plus 4y. It's not a necessary step, it just makes it a wee bit tidier. So then at your point 2, 3, just sub your x equals 2 and y equals 3 into your dy by dx function, and that gives you, after a wee bit of working out, that gives you 9 over 14. So remember, dy by dx gives you the gradient of the tangent. We're looking for the gradient of the normal. So negative reciprocal 9 over 14 to give you minus 14 over 9. So your normal, this is equation y equals mx plus c. So sub in your minus 14 over 9 for your m. And then all we do is substitute in the 0.23. So at the 0.23, your y value is 3 and your x value is 2. So 3 is equal to minus 14 over 9 upon the 2, then plus the c. Minus 14 over 9 is minus 28 over 9. Bring that minus 28 over 9 to the other side, it becomes plus 28 over 9. So 3 plus 28 over 9 is equal to your c, which works out to be, hopefully, 6 and 1/9. And the last bit then, you've got your c, you've got your m, so therefore your normal is y is equal to, so that's just my minus 14 over 9, so y is equal to minus 1 and 5/9 x plus 6 and 1/9, and that's it. Okay, you're now ready to do topic 6, topic 6, differentiation B, then exercise 1. Exercise 2 is a homework exercise, so we'll just leave it out at the moment.